Hello everyone, welcome back to Calculus BC. We're in lesson 33 where we're continuing on with integration by parts. So in this particular video we're going to talk about repeated integration by parts. So this means that when we actually do the integration by parts formula, the integral that's left is not easily integrated. So let's actually start by what we've been doing before and figure out what our u and our dv is. So as I always do, I write out the u, the du, v, and dv. So again, for the third video, we're still talking about our friend ILATE. So we have an exponential function and we have a trig function. So based on what you see here, our u is going to be the trig function. So sine of x, and then everything else in the integral is going to be the dv. So this is going to be ex dx. So just like before, ladies and gentlemen, we're going to take the derivative of u to get du, which is going to be cosine of x dx. And we're going to integrate e to the x dx to get v, and that's going to be e to the x. So we're going to now integrate e to the x sine x dx. And I'm going to pause for a second to write the formula up for you guys. So here we go. We found the u, we found the dv. So first thing we're going to do is we're going to multiply u times v. So we're going to get x times sine of x. And then we're going to subtract, and we're going to do the integration of v, which is going to be e to the x, times du, which is going to be cosine of x dx. Now, in the previous two videos, this was really easy to integrate, right? It was very easy for us to do. But we really haven't changed stuff very much right here. You guys can see that we started with e to the x sine of x, and now we're with e to the x cosine of x. So this is why this is called repeated integration by parts. So we now have to use this as our new problem. So now we will integrate this. So we're going to do another u, du, a v, and a dv. So just again, we're using integration by parts by ILATE. So we have a trig function and we have an exponential. So just like in the previous example over here, we're going to make our u equal to our trig function, and everything else we're going to make our dv. So we integrate dv, we get v. We take the derivative of u, we get negative sine x dx. So what I want to do here is I'm going to rewrite this, and I'm going to keep writing the equation out because of what's going to happen next. But I wanted to say that we want to be very careful about this. So I'm going to do minus in a huge bracket because I want to subtract all of this, the whole thing. So just like before, we're going to multiply u times v. So it's going to be e to the x cosine x minus the integration of v du, which is going to be e to the x times negative sine x dx. So I'm subtracting this whole thing. I'm subtracting this whole thing here. So what I want to do now is just rewrite this by distributing the negative. So I'm going to go ahead and do e to the x sine x dx is equal to e to the x sine x. A lot of this is just rewritings. I'm going to go ahead and distribute the negative. So it's going to be minus e to the x cosine x. Now this negative sign and this negative integral is going to make it positive. So when I distribute the negative, that's actually going to be negative again, the integration of e to the x sine x dx. Now you're probably thinking, oh my God, we have to do it a third time. Well, we do not. What we can now do is we can add to both sides. We can add on the right-hand side e to the x sine x dx. And on the left-hand side, we can add the integral of e to the x sine x dx. So what does that do for us? Well, if I add e to the x sine x from the right, then that's actually going to eliminate this completely. And I can see this part, well, the integration of e to the x sine x dx plus e to the x sine of x dx is actually simply equal to two of them, right? So I can actually take two of them. So I can get rid of this and actually say that there are two of these things there now. And so remember that I can integrate e to the x sine x dx is equal to e to the x sine x minus e to the x cosine of x all over 2. And then we have our lovely plus c that we always like to do here. We always want to make sure that this value here is going, we want to get to the point where when we keep integrating by parts that we get this back. We get this back. Is it always going to be 2? No, we'll do an example of that in a second, but that's the idea that we want to do with this problem. All right, let's do one more example, see what we can do with it. So I jump down here to x squared sine of x dx. And so this one's actually really important because we're going to do this one the long way, and then I'm going to show you guys a shortcut to do this problem and when you can use the shortcut. So just like before, we're going to write out our little fun stuff here. And so we have ilate one more time. So I'll write it like this time. So ilate. Well, we have a trig function and we have a algebraic function. So again, the higher up it is, it's going to be the u. So our u is going to be x squared, and then our du is going to be the trig function. So sine of x dx. And we're going to take the derivative of this. We're going to get 2x dx, and we're going to integrate this, and we're going to get negative cosine of x. Negative cosine of x. So let's continue on with our integration by parts. So if I do the integration of x squared sine x dx, it's equal to the product of u and v. So it's going to be negative x squared cosine of x minus the integration of v times du. So you guys can see there's a negative right here with the cosine. So I'm going to go ahead and just pull that negative out and make this a positive sign. So this is going to be 2x cosine of x dx. And so what we're going to do now is, one more time, we have to do the integration by parts because we can't integrate this very easily. We still have an algebraic function and we have a trig function. So we're going to go to u, du, v, dv. And I'm going to tell you guys there is a shortcut to this particular example, and I'll show you guys it one second. Again, we have an algebra function and we have a trig function. So our algebra function is going to be u, and then our trig function is going to be the dv. We're going to integrate cosine, and we're going to get positive sine of dx. And we're going to take the derivative of 2, and we're going to do 2 dx. So just like before, we're going to rewrite this function one more time. We'll get negative x squared cosine of x, and then we're going to do plus. Since it's plus, we can go ahead and say, well, this is going to be the product of u and v, so it's going to be 2x sine x minus the integral of 2 sine x dx, which is v du. And so we finally get to a point where this is actually easy. We don't have to integrate this by parts. We know how to integrate negative 2 sine of x dx. Well, if you're watching the video, you know how to do that. So integration of x squared sine of x dx is going to be equal to negative x squared cosine of x plus 2x sine of x. If I go and do minus 2, I can pull the negative 2, I can pull the 2 out, which would be negative 2, and then be the integration of cosine. Well, the integration of sine, which would give me a negative cosine, which would then change this to a positive cosine plus c. And this is the answer for this problem. So I'm going to finish up this lesson by showing you guys the shortcut you can do for these repeating trig functions, but there is one criteria that has to be true. You have to have a trig function. You have to have an algebraic function that when you keep taking derivatives of it, it will eventually get to 0. So here's how this actually works. So let's talk about what to do for the shortcut. Again, so up here in the example we did at the first part of the video, we cannot use the shortcut because we do not have a function that when you keep taking the derivative, it's going to be 0. E to the x is always e to the x. Sine is going to be back and forth between sine and cosine. So for this example, x squared, we have the integral of x squared. I'm just going to write it down here because I need room so you guys can see it. So this was the original problem. So what you're going to do is you're going to do u and you're going to do dv. And so u is going to be always your algebraic function, and then dv is going to be your sine of x. You're going to find the derivative of this, and you're going to get 2x. You're going to find the derivative of this. You're going to get 2. You're going to find the derivative of this. And you want to keep going until you get 0. So you're going to take derivatives till you get 0. We're going to take the antiderivative of sine, which is going to give us negative cosine. And by the way, you guys, it's so easy to do it this way, right? It's always easy to just look at it like this. So when we're doing sine, cosine, negative cosine, sine, when we're integrating sine, we get negative cosine. When we integrate cosine, we get negative sine. We integrate negative sine, we get cosine. And so this is what we want to do for these particular examples. So this is our setup for our shortcut. So we're again taking the derivative of u, we're integrating dv until we get to 0 on the left-hand side, and then we can stop right here. What we now do is this. We're going to take this x squared with this dv. We're going to take this 2x with 1 below it. And so we're going to do 2 with cosine. So this x squared with this dv, so we go 1 below it. The other thing that we want to make sure that we're clear about is that this is always going to be positive, which means we're going to keep the sign. So this just means we keep the sign. This is going to be negative, so it's going to be the opposite sign, and this is going to be positive. We're going to keep the sign. So in this case, plus means that we keep the sign of our product, and negative means that we're going to change the sign of it. So as you guys can see here, if I follow this, then I'm going to have x squared times negative cosine, which again is, we're going to keep that sign, so it's going to be negative x squared cosine of x. We're going to do 2x times sine of x, but we're going to change the sign. We're going to change the sign. Or we can think we'll multiply by a negative, right? That's an easy way to. So it's going to be negative 2x sine x, but we're going to change the sign so it's positive. We're going to multiply 2 times cosine, but again, we're going to keep the sign. So it's going to be 2 cosine of x, and then plus c. And if you guys look at what I wrote here in orange and you compare it to what I wrote here in red, they are the exact same thing. And this is a legit, totally legit way of doing this problem where you do not have to do the integration by parts. And again, I'm going to stress it one more time to finish out this lesson. This only works if one of your functions is an algebraic function that can easily get to 0 once you take its derivatives. So that's it for me for integration by parts. I hope this was helpful for you guys, and I will see you guys in the next video. We start talking about partial decomposition. Take care.